right, guys, here we are again. Once again, y'all, it is just math, y'all. We are in Cal 1. We are going to use the definition of derivative today to solve some problems. So, I'm just going to jump right into the first one here. Now, this is using a little bit different notation for derivative than we went over in class. But dy dx does mean the derivative of y with respect to x. And so that notation means the derivative. And then this second notation has this bar down the side, and then it's got x equals 5 at the bottom. That just means to plug in 5. That's a notation for evaluate. It's a new notation that you're not familiar with for evaluate. Okay, so this first function is y is equal to 6x squared, and we want to do the derivative of this with respect to x. So we're going to do our, finding my page. Hold on. Okay, so we're going to do this problem. And here we go. So, we're going to do f of x plus h minus f of x divided by h, and we're going to do the limit of that as h approaches 0. So for this first one, we're going to do 6 times x plus h squared minus 6x squared all over h. So I'm going to multiply that out on my scratch paper. I get x squared plus 2xh plus h squared, and that's multiplied by 6 minus 6x squared, okay, all over h. So now, when I distribute, I'm going to get 6x squared plus 12xh plus 6h squared minus 6x squared. So those go away all over h. Now, hold on. I think I forgot something. On your homework, the first box, they want that. I'm pretty sure that's what they want. Okay, and then after you simplify it, which is what I was doing, I had to erase it. The 6x squareds cancel, and you have 12xh plus 6h squared over h. Okay, so now we're going to divide the h out. They're going to all cancel, not all of them. We get 12x plus 6h, and that goes into that box. No, that's not right. We do the limit of this. So the limit as h goes to 0 of 12x plus 6h. That goes to 0. My answer is 12x. That's what you're going to put in this box. All right, so this is the derivative. 12x is the derivative. That's it. That is the official one. You take the limit of this expression as h goes to 0, and you get 12x. And then down here on the second part, you evaluate. You plug in 5. I plug in 5. 12 times 5 is 60. I plug in negative 6. 12 times negative 6 is negative 72. So check your My Math Lab to make sure this was right. But yeah, this is what I'm pretty sure they wanted you to do. Let's look at another one. Okay, so now in this example, we have a rational function. So this one is much more interesting than the one we just did. Okay, so this one is a rational, and then they want us to plug in the two numbers after we do it. So here we go. So we're going to do f of x plus h. Let me put this over the side. We're going to do f of x plus h minus f of x over h, and then we're going to take the limit as h goes to 0. Okay, so here we go. So it would be limit as h goes to 0. All right, so we're going to do 6 over x plus h plus 1 minus 6 over x plus 1, all of this over h. Okay, so now I've got to simplify this severely. And so I've got a rational expression in the numerator, so I'm going to need to simplify that rational expression in the numerator. And so here we go. I'm going to have 6 times x plus 1 minus 6 times x plus h plus 1 all over the common denominator, x plus h plus 1 times x plus 1, and this is all over h. Now when we did this problem before, I put the h as times 1 over h, and that's still correct. All right, but this all over h becomes that times 1 over h. All right, so now we'll continue to simplify this. So I have 6x plus 6 minus 6x minus 6h minus 6 all over x plus h plus 1, x plus 1 times 1 over h. Okay, so now stop the video and get caught up with me, because I told you I'm going to go fast on these. So those go away and those go away. And so I have negative 6h over x plus h plus 1, x plus 1, 1 over h. And so now those go away. So now that's the expression I'm going to take the limit of as h goes to 0. So limit as h goes to 0. Right? So the limit as h goes to 0, h is 0, and I have a negative 6 over x plus 1 squared. That's what I get. So f prime of x is equal to negative 6 x plus 1 squared. Okay, that's part 1. All right, so now I'm going to plug in a negative 1/3, and I get negative 6 over negative 1/3 plus 1 squared. Okay, so that's negative 6. All right, now you've got to be able to take a third away from a whole and leave you with 2/3. What'd she say? It's just math, y'all. It's just math. You take one whole and subtract 1/3, and you get 2/3. So this is 2/3 squared, which is negative 6 over 4/9, which is negative 54 over 4, which reduces to negative 27/2. All right, and now we're going to do our derivative evaluated at 3. Almost out of room here. And we got negative 6 over 3 plus 1 squared, which is negative 6 over 4 squared. It's negative 6 over 16, which is negative 3 over 8. Okay, so there we go. The derivative is here. That is the formula for the slope of a line tangent, okay, or a function of slope of a line tangent. And when your x is negative 1/3, the slope of that tangent line is going to be negative 27/2. And when your x is 3, the slope of that tangent line is going to be negative 3/8. All right, let's do one more real fast.